Hi. Okay, so this is part 2 of our photoelectric emission concept. Okay. We'll be learning today regarding how to find stopping voltage. This is a new term for you guys, stopping voltage. Okay, I'll be teaching you guys those. Okay. Now, all those photoelectric emission I was talking about in my first video, you'll get to know more about it from here. Okay, as well. So I'm just creating a new page so that I explain you guys. Okay. So now let's try to learn about stopping voltage. Okay. Let's say I have two plates over here. Just see this diagram. Huh? Just see this diagram. I have two plates here. One is negatively charged and one is positively charged. Okay. And when we shine light, okay, when we shine light onto plate P, which is negative, electron gets ejected because I already told you in the first video, when the light is more than threshold frequency, and when the light has and when the photons have energy equivalent or more than work function, okay, electrons do get emitted. So here that's what going to happen. Okay, and this is actually one of those experiments we can do to see that how we know that threshold frequency exists, work function exists. Okay, this is how we would know. Let's say I have two plates with me, plate number 1 and plate number 2. Both are connected, and both are connected to a sensitive galvanometer. Let's say we can say a galvanometer, which galvanometer shows you the presence of current, and also emitter. You can also use a micro sensitive micro emitter. You can just write this symbol also. Any one of these two is acceptable. So let's say this is negatively charged and this is positive. So when we shine the light, okay, if the light is having more than threshold frequency, we will see the electron from here will get ejected and it will get attracted because this is oppositely charged, right? The electron will get attracted over here. When many electron goes from this plate P to plate Q, there is a flow of electron over here. And how do we know there is a flow of electron? With the help of a milliampere, a milliammeter, or a galvanometer. And what if we have a light which has a less than threshold frequency? Let's say if we shine a light which is less than threshold frequency? In such cases, okay, no electron is getting emitted because we know that less than threshold frequency no electron gets emitted, and therefore the galvanometer or your milliammeter will give you show you a reading of 0. So that's how we know threshold frequency does exist. Okay, so now what is this experiment is about? This experiment is to find something known as stopping voltage. We write its symbol Vs, small s down. This shows stopping voltage. Now, okay, wait, I think my charge is going, so let me just pause it. Okay, welcome back. Okay, we are going to learn about stopping voltage. Now, what is the stopping voltage? I will explain that later. Let's see what happens. Let's do from A to Z, from basic. So when we shine a light more than threshold frequency on P, okay, when we shine a light more than threshold frequency on P, electron gets emitted. Okay, and when the electron gets emitted, they get attracted uh, towards this positive plate over here. Now, if we increase the intensity of the light, I hope you guys know what is the meaning of intensity. Like when you see a torch light in front of your eyes, very close to it, it's very intense, right? The brightness, intensity actually means brightness, intense light. So if you increase the brightness of the light, more photons, remember, one interaction between electron and more interaction between electrons and photons. So more interaction, therefore more electrons gets released, and if more electrons gets released, more electron gets attracted towards this positive plate, and you get more readings over here. And that's how we know that intensity, if you increase the intensity of light, okay, if you increase the intensity of light, more electron gets ejected because the current in the circuit increases, the reading on this galvanometer and this milliammeter increases. Okay, now let's talk about stopping voltage. Let's say somehow we can make this plate negative potential. If we make this plate negative potential, you can see now, before there was an attraction, now there is a repulsion. There is now a repulsion over here. Okay, it's like you are going in a straight road and you can flow easily, but suddenly there is a bump, like there is a small hill, so you need to climb it, right? Now if you see a straight road, you feel like to walk, but when you see a small hill, you will not feel like to, because if you have energy, yes, you can walk and you can go to the next level, next side of the mountain. Same thing here. Now let's say 100 electrons are getting ejected. Before, hundreds were ejecting and hundreds were reaching on this side because there was an attraction. Now there is no attraction. There is a negative charge over here. So there is a repulsion. Let's say out of 100, maybe 95 reached here. Okay, 95 reached over here. What happened to the rest of the 5? Rest of the 5 did not had enough energy, okay, to cross from this part of the plate to this part of the plate, because now there is a repulsion. They could not overcome the repulsion. They could not overcome the repulsion. That is the reason. Let's say, for example, this negative potential here, therefore negative voltage, let me increase it. Let's say it was -1 volt now. Then I made it -2 volt. If I increase the potential, it looks like your hill now got a bit more higher than before. Okay, so let's say there were 100 people over here. Out of 100 people, 95 people crossed it because they had the enough energy. But now the hill has increased, the size of the hill has increased. Now out of 95, maybe 70 will cross because they have enough energy. Okay, so now let's say out of 100 electron, maybe 75 electron reached over here, because now there is a repulsion and the repulsion has increased. The force of repulsion has increased because why? You have increased the negative voltage, the negative potential of this plate. You have increased it. So therefore the repulsion have increased. Okay. Now let's keep on increasing as long as basically we will keep on giving higher and higher mountain, as long as even the guy out of those 100 guy, most energetic guy cannot climb it. Okay, so this is the final point. Basically most energetic guy cannot climb this, so this is the final mountain you can give. Okay, so that's what happening over here as well. That's what happening here as well. So let me just rub this. So what's happening, as you increase the voltage more and more and more, less and less electron keeps on reaching here on this plate, and you will say, how do I know the less electrons are reaching? Because your current value will keep on decreasing as you increase the negative potential, because less electrons are coming over here, so therefore less current will flow. The value of magnitude of the current will be less. Now at one particular voltage, we call it stopping voltage, -2, -3, -4, -5, keep on going. At one particular voltage known as stopping voltage, even the electron which had the highest kinetic energy cannot reach over here. Basically when your value becomes 0, when your current value becomes 0. So the voltage at which, the negative potential at which, or the potential at which even the electron with the highest kinetic energy cannot move from plate P to Q is known as stopping voltage. I hope you understood this. There are more explanations coming. Let me read this whole thing for you. See, the investigation is of photoelectric effect may be carried out by using apparatus shown above. This is galvanometer. You can also use a milliammeter over here. Light of known frequency, so we will use a light of known frequency, is shown onto the metal electrode P. Okay, so we are shining the light over here, and if the light is more than threshold frequency, there will be an ejection of or emission of electrons. Photoelectrons from P travels towards C. Why? Because they get attracted. I already explained that. This completes the circuit and current is detected at the galvanometer. The maximum kinetic energy of the ejected electron can be found by making C negative. So if you want to know what is the maximum energy of electron, which electron has the maximum kinetic energy, if you want to know how much is it, you can actually use this method. Respect to P, you can increase the, how do you do? Instead of positive, make it negative potential. As this potential difference is increased, what is this? By negative with respect to C. As this potential difference is increased, the number electron reaching C decreases. Very few electron has the required energy to overcome the potential barrier. By potential barrier, they means the repulsion which you are increasing with each increasing potential over here. Okay? The repulsion between the electron and the plate is increasing now. Before there was attraction when it was positive, now it is negative. So there is a repulsion. At certain potential difference, they are talking about stopping voltage, even the electron with the most kinetic energy fails to reach C. This potential is called stopping voltage. You guys need to learn this paragraph. Okay, now what will happen if I increase the frequency of this light? Okay, let me redraw them again. What if I increase the frequency of this light? I already mentioned in the previous video, if you increase the frequency of the light, the energy of the light is more. The energy of the light is more. If the energy of the light is more, now the electron has more kinetic energy than before. Like for example, let's talk about that particular guy who could not cross this high mountain. For example, you give him some kind of drugs, let's say, okay, some kind of strength enhancement drugs. Okay, so he will now climb this also. What do you do now to test him? You even make a higher mountain. Okay, so his stopping voltage, the mountain, the height of the mountain which can stop him has increased now because you have given him more energy. Same thing here. If you shine a light with more frequency, okay, if you increase the frequency, the stopping voltage increases. That means before this electron had, let's say, 100 joules of energy. Now it has 120. Definitely it can overcome this repulsion. It can reach over here. So now you have to, before, let's say your stopping voltage was minus 8 volt. Now you have to make it minus 10 volt to stop it. So if you increase the frequency, okay, the stopping voltage also increases because now this electron has more kinetic energy, so it can overcome the repulsion. Okay, so now if you don't want this electron to reach here, what you have to do? You have to increase your stopping potential or stopping voltage. You have to increase it. So remember, if frequency increases, stopping voltage also increases. If intensity increases, stopping voltage remains the same, but if you increase the intensity, more electrons are released, right? So therefore current increases. Okay, if you increase the intensity, your stopping voltage remains the same, but your current increases. Why? Because more intensity means more electrons gets emitted. Okay, so it's written over here, as the frequency of the incident light increases, stopping voltage also increases. Why? Kinetic energy of the emitted electron increases, but does not affect the current. Okay, and I wrote them in bold letters. Okay, so learn them. As the intensity of the light increases, stopping voltage remains the same. I already mentioned that. Why? Stopping voltage remains the same because intensity does not increase the energy. Frequency does. Okay, but current increases as the number of electron emitted increases. I hope you guys understood this topic. Let's go to the next topic. This is a diagram which I think they did ask in, like, what? They never asked this, but I think I did see this such kind of question, what, 7 years back or 6 years back? I don't remember. In some question bank it was there. So let me teach you this I versus voltage graph. Okay, let me draw them and show you. Okay, then I will explain the graph over here. So for example, if you draw current versus voltage graph, this is how the graph actually looks like. This is how graph actually looks like. Okay, you can see that this is I and this is voltage. This is 0 voltage and these are negative voltage over here. You can see when the voltage was positive, you can see from right side, when the voltage was positive, your current is increasing, and after some point the current becomes steady. Why does it become steady? You don't have to know that. Okay, you call it saturation current, if I remember. Yes, you call it saturation over here. Okay, now, but can you notice, as you increase the potential voltage at the negative side, because of the repulsion, current is decreasing. Why current is decreasing? Because less and less electrons is reaching from, let's say, plate P to plate Q. Because why? There is a repulsion now. Okay, when electron gets emitted. So at one point the electron decreases. At one point what happens? Even your whole current becomes 0. Why? Because the electron with the highest kinetic energy cannot go from this plate to this plate. Okay, so this is what we call it stopping voltage. Now then I can ask you, will they ask me to draw a separate diagram if frequency increases? Definitely they will. So let me take a black color and let's say let's draw a diagram where the frequency increases. Okay, let me shift this whole graph towards the right. I already did towards the left a lot. Okay, this is fine for me, and let me just clear this bit out and let me draw the diagram. Okay, so if I have to draw if frequency increase, let's say there is a light, we used a new light whose frequency is more, so the graph will, the shape will almost be the same, but your voltage will increase, your stopping voltage will increase, but your current will remain same. That's what we learned here now. That's what we learned. The voltage increases but the current does not change. So you see the current did not change, okay, but the voltage increased. Okay, what if this say when intensity, so this is high frequency, okay, this is high frequency and this is normal frequency. You can see normal frequency, the stopping voltage is this. In high frequency, the stopping voltage, that means the voltage required to stop the electron with the highest kinetic energy has increased. Okay, what if they say us to graph with, what if we increase the intensity? If your intensity is high, your voltage, stopping voltage will remain the same, but your current will be very high. So you can see the value of current has increased sharply, okay, but stopping voltage is same. I hope you guys understood. These are the graphs which I just explained. Okay, these are the graphs which I explained. Have a look at it at your notes. Okay, now from now on we should know how to calculate energy in electrovolts. Okay, I'll explain that. What is an electrovolt or something like that? You know, kinetic energy formula is QVS. We know kinetic energy formula is QVS. We have two kinetic energy formula. One kinetic energy formula is half mv square. Another kinetic energy formula is charge of the particle into voltage. Remember this, or Vs means stopping voltage. Okay, instead of writing Q, we can also write EVS. Instead of writing Q, we can also use the word EVS. E means charge of one electron. E means charge of one electron. And how much is that? You need to by heart this, and it is given in backside of the paper as well. 1.6 into 10 raised to minus 19 coulomb. Okay, so when we write an equation, so remember this is the energy we need to, the electron should have to overcome the repulsion. Okay, this much energy. Okay, so also sorry, this much energy the electron has after emitting. Saying, but we studied half mv square, so we can write both the equation from now on. HF, we already learned this in our first part of the video. In second part of the video, everything is same, only this is giving an EVS. Okay, and there is something else as well. It is not as easy as this. Okay, there is something else as well. Remember, we have to now learn a new unit. You should know that the unit of energy is joules. Unit of energy is joules, right? Now we have to learn a new unit of energy, that is electrovolts. And in shortcut, we can write it EV. What is the meaning of this electrovolt? Electrovolt is the energy an electron has when it goes between two plates with a potential difference of 1 volt between both the plate. Okay, this is the energy it gains. You know, na, this is positive and this is negative, let's say. So this is the energy if an electron goes from between the two plates who has a potential difference of 1 volt. Okay, the energy this electron gains is known as electrovolt. Before we can measure it in joules. If we are using this equation, we will measure it in joules. If we are doing this equation, we have to, everything should be in electrovolt. Remember that. We will learn this in more detail once I'll start making videos regarding calculations. Okay. So, but there is a conversion. Remember, 1 kilometer is 1000 meters, so and so, all those things. There is a conversion also there. So this is the conversion you guys should remember, that electrovolt. That means 1 electrovolt is 1.6 10 raised to minus 19 joules. Remember that. 1 electrovolt is 1.6 into 10 raised to minus 19 joules. Okay. So once I do questions from question bank, you will understand this better. Remember, if electrovolt is given, your answer is given in electrovolt, your question is given in electrovolt, use this equation. If it is given in joules, use this equation. Okay, and here everyone is in electrovolt if you want to do the sum, and here everyone has to be in joules if you want to do the sum. Okay, we will see this later on. Okay, now let's talk about intensity. Remember, intensity is power divided by area. Intensity is power divided by area. For example, if you have a source of light, the closer you are to that source of light, the more you feel the intensity of light. But if you go further away, your intensity of light, the intensity which you feel decreases the further you go. Why? Because the intensity, let's take an example of a candle. The intensity spreads. Okay, the intensity spreads like a sphere, like a three-dimensional sphere. Imagine this not as a circle but as a sphere. Okay, so the further you go from the candle light, the less the distance become, the less the intensity becomes. So intensity is equal to the power divided by the area it spreads. Most of the time the area is actually 4 pi r square. Why? Because the intensity, it spreads like a sphere. Okay, intensity of light decreases, so everything spreads like a sphere. That is the reason we most of the time we use the area 4 pi r square. Intensity is also known as, I think, radiation flux, if I am not wrong. Yes, intensity has another intensity. I'll show you an example of intense. Let's say a light coming towards your eye, and these are the lights coming towards your eye. Can you see this intensity is more? So that means if you are closer to a light source, your intensity is high. If you are further away from the light source, your intensity is less, and it spreads like a sphere. So that is the reason we have an area of the formula of the sphere. And my English is pretty bad, okay, so I'm sorry about that. Okay, intensity is power by area. Intensity is power by area. Okay, power is in watt, area is in meter square, and intensity is watt per meter square. Okay, you guys should know this. Okay, intensity spreads like a sphere. Just remember that. The further you go away from the source of light, the less the intensity becomes. Okay, I think these only you're supposed to know. The unit of intensity is watt per meter square. The intensity of light decreases as we go away from the source. Now comes the biggest explanation, and these things I'll explain in another video. For the time being, let us learn only these stuffs. Okay, let me teach you. Okay, by the way, before I go, I really need to show you guys a video regarding this. Okay, let me show you guys a video regarding this. Okay, I'll start the recording of the video. Just listen what he's saying, okay? And in between I'll stop and I'll explain you guys.
Electric effect was a very important discovery that was made in the early 1900s and was first correctly interpreted by Albert Einstein. The photoelectric effect shows us that when light strikes a metal surface,
you can see here that more and more electrons are reaching from this plate to this plate. His intensity is normal, his frequency is also normal right now. Okay, and you can see there is a detection of current over here. There is a current over here. Okay,
electrons are ejected from that metal surface. The first important thing you need to know is that the brighter the light, the greater...
Can you see the more intensity of light he has increased? You can see the amount of electron that will be emitting from this particular plate will increase, and you can see that the graph also, current versus intensity. As the intensity increases, current also increases a lot.
The current.
You can see number of electrons are increasing.
That is, the greater the number of electrons.
And when he decreased the intensity, the number of electron emitting is also less.
They're ejected from the metal. So a brighter light creates a larger current, which means more electrons ejected from the metal. You'll notice it's a linear relationship that goes through zero. So no matter how low the intensity is, as long as you're not at zero, you'll still have some electrons being ejected from the metal. Okay, the second thing that you need to know is that these electrons that are ejected from the metal have a certain amount of energy. That energy was determined by using a voltage source.
So what he's going to do is he's going to change the polarity now. He'll make it negative. He'll make it negative, okay, and he will make this plate negative potential, and all of these electrons have an energy. If they have enough energy to overcome the repulsion, they will reach this plate, okay. If not, they will not reach. And see what happens now.
Try and stop the electrons. So we make one of these plates negative, and it starts
Can you see the electron starts repelling now? They cannot reach over here.
repelling the electrons away from it. And when we hit just the right voltage, we'll get it so that none of these electrons can.
You see, at 2.60 is the stopping voltage here, because at that voltage none of the electron is reaching to the other plate.
Make it across to the other plate. At that point, the current will drop down to zero.
Current is zero, and that's how we know that this is a stopping voltage.
Once we have the current down at zero, we can find the energy of these electrons by using the formula. Voltage, that's the voltage of our voltage source, is equal to the kinetic energy of the electrons. Voltage equals
I
work
think this much is enough, okay?
over charge.
This is energy is equal
Again,
to
the work is the kinetic energy of electrons. The Q is.
Okay, so welcome back to this particular page. Now we have seen the video. Okay, you know what I'm going to do? I'm going to make another part of this video, and I'm going to explain wave particle duality, because it is a pretty big concept to learn. Okay, I think this 26-minute class is more than enough right now. Okay, thank you.